Hi all. So in this particular video, we'll try to find out the shape functions of an element called as a quadratic element. We'll first look into the characteristic equation of this particular element, and then we'll try to understand why this particular element has been given the name as quadratic element. So a quadratic element will fall under the category of a higher order element, where the second node will be located exactly at the midpoint. So this is an extension of a bar element. A bar element was basically a simple lower order element. So which means it just consists of an element. So we'll have node number 2 over here and node number 1 over here. Put together, this is just a single element. So here again, node number 1 as well as node number 2 are located at the edges. So this will fall under the category of lower order element. Whereas a higher order element is a little bit different, wherein we'll be having nodes which are present at intermediate positions or somewhere on the boundary of the particular element. So this again will be having a third node which will be located within that, or let me say on the boundary of the particular element. So quadratic element will fall under this category. Sorry. And we'll be able to find that the second node is located exactly at the midpoint. Okay, so this is what I've mentioned over here. We have a single element, node number 1, 2 and 3, and node number 2 is located exactly at the midpoint, L by 2 and L by 2, right? Next, we'll try to fix on to the Pascal's triangle over here. So once we try to fix on to the Pascal's triangle over here, we'll be able to find that node number 1, 2 and 3 are fixed in this particular category. Hence, again we'll be able to find out the characteristic equation of this, which is basically phi is equal to A, which corresponds to this particular term, plus bx, which will be corresponding to this particular term, and then plus cx square, which again will be corresponding to the last x square term over here. So out of which a, b and c are constants, and we are going to find out the value of these constants basically. Okay, so as I told you, this is the characteristic equation of this particular element. Now if you look into this particular equation, it's basically a quadratic equation, hence the name quadratic element has been given to it. Okay, so I'll repeat the statement once again. Quadratic element, the name for this particular element is basically derived from the characteristic equation, because the characteristic equation is actually a quadratic equation, right? With further no delays, we'll look on to the point where we are going to find out the values of the constant a, b and c respectively, right? So there are three boundary conditions. Substitute all the three boundary conditions, we'll be able to find out the values of a, b and c. What are those three boundary conditions? Three nodes basically. Okay, so three nodal points we are going to consider. So the first node point is where phi is equal to phi 1 and the value of x is equal to 0. So if you try to recollect it, then we'll be able to understand it on a much clearer note. We had an element. So the first node was present over here, second node exactly at the midpoint, third node at the extreme corner. So we'll start the x from this particular position, and obviously we know that L by 2 is the distance between the first and the second node, and similarly the same distance will exist between the second and the third node. Okay, so with this condition only we are finding out the shape functions. So the next boundary condition is at this particular point node where phi is equal to phi 2 and the value of x is equal to L by 2, and obviously the third node point is where the value of phi is equal to phi by 3 and x is equal to the total length of the element. So these three boundary conditions will be used, and using these three boundary conditions we are trying to find out what is the value of the constants a, b and c, right? So we'll go for the first boundary condition. So the first boundary condition, as we know, phi is equal to phi 1 and the value of x is equal to 0. So this we are going to substitute in the characteristic equation, and we know what is the characteristic equation. Phi is equal to so phi is equal to a plus bx plus cx square. Obviously we know the value of x is equal to 0 and phi is equal to phi 1. Substituting it, we are going to have it as phi 1 is equal to a plus b into 0 plus c into 0, or basically phi 1 is equal to a. So now we have found out directly what is the value of the constant a. So this is what we are trying to do in this particular step. So we have seen it, we have substituted all the boundary conditions. Just make a small correction over here. This particular value is actually a and this is phi 1. So now you will be having phi is equal to a. Okay, so the typo error is basically phi 1 is equal to a plus b into 0 plus c into 0. So this value will cancel off, this value will cancel off, the only remaining term is this. Okay, so as stated in the next step, substitute it in the characteristic equation. Characteristic equation is a plus bx plus cx square. Substitute the value of a, so basically it is phi is equal to phi 1 plus bx plus cx square. So this equation will use for finding out the value of b as well as c directly. Okay, so this is the equation, and this equation we are going to use it for finding out what is the value of b and c. Okay. Right. So next we are going to go for the next boundary condition. Phi is equal to phi 2 and x is equal to L by 2. So as usual, what we do in the previous step, we are going to repeat the same thing. So characteristic equation will be considered. A is equal to phi plus bx plus cx square. We have modified this. We know what is the value of a. So phi is equal to phi 1 plus bx plus cx square. So now substituting the boundary condition, x is equal to L by 2 and phi is equal to phi 2. So it is phi 2 is equal to phi 1 plus b into, instead of x you are writing it L by 2 plus c into L square by 4. Okay, because we have the square term over here. Fine. So now let me just rearrange it. So phi 2 minus phi 1 is equal to bl by 2 plus cl square by 4. So this we are going to consider this as equation 4, right? So this is what we'll be doing in this particular step. Substitute the value of x as L by 2, we'll be getting this equation. Just rearranging the above equation, this is what we'll be getting. So what I've done is I've just changed this phi 1 and then brought it on the other side. So this becomes equation number 5. The last boundary condition is again wherein you're going to substitute phi is equal to phi 3 and x is equal to L in that equation 3. So what is the equation 3? If you try to recollect it, it is basically phi is equal to phi 1 plus bx plus cx square. So here just substitute what is the value of x, which is L. So once you do that, it is phi 1 bl plus cl square. Rearranging it, you're going to have this as phi 3 minus phi 1 bl square and cl square. Here the most important point that we have to consider is this. The previous equation, this equation number 5 is very, very important. Similarly, equation number 6 is also very, very important. So basically we are going to consider equation 5 and equation 6. Using that particular equation 5 and 6, we are going to find out what is the value of b and c, right? So we'll get to the next step. So we are going to find out what is the value of the term c. So what we are trying to do is, you can find it over here for for finding out the value of C, equation 5 will be multiplied by 2, right? I'm sorry. So if you try to recollect it, you'll be able to find that equation 5 basically is phi 2 minus phi 1 is equal to BL by 2 plus CL square by 4. So this will be multiplied by 2. So this whole equation will be multiplied by 2. So this is equation 5. So this will be multiplied. So what happens is, it is 2 phi 2 minus 2 phi 1 is equal to BL plus CL square by 2. Okay, and we had the fifth equation, I'm sorry, sixth equation, just multiply it by minus 1, or we are just changing the sign of the sixth equation. Okay, so sixth equation, recollecting it, it is just phi 3 minus phi 1 is equal to BL plus CL square. When we just multiply it by minus 1, what we have done is we are changing the sign. So this becomes minus phi 3 plus phi 1 is equal to minus BL minus CL square. So now you can just add both these equations. So here you have minus 2 phi 1 and plus phi 1. So minus 2 phi 1 plus phi 1, so which will give you as minus phi 1. Here we have phi 2, so plus 2 phi 2, and finally minus phi 3 is equal to, now you can cancel off this B term as a whole, just C term is remaining. So if you do the math, you will be able to get it as CL square by minus 2. Right, now we can just rearrange this equation, which is basically minus phi 1 plus 2 phi 2 minus phi 3 is equal to minus CL square by 2. Rearranging this, again just removing the negative sign, it will be phi 1 minus 2 phi 2 plus phi 3 is equal to CL square by 2. What we are interested is finding out the value of C. So others bring it to the other side. So it is 2L square into phi 1 minus 2 phi 2 plus phi 3. Okay, so this is what is done to find out what is the value of C. Okay, let me just remove this. We'll get back to the slide. So as I stated, equation 5 is multiplied by 2, and then equation 6 is multiplied by minus. A negative sign will be induced in the sixth equation. Just adding up both these equations, we'll find out, or we'll be ending up with the C term as a whole. Okay. So again, C term is considered as a whole. So the same procedure is going to be repeated, but the only difference is here we are going to find out what is the value of constant B. So as we know, one second. So as we know, phi 2 minus phi 1 is equal to BL by 2, and then plus CL square by 4. So what we are doing is we are multiplying this by 4. So what happens is it is 4 phi 2 minus 4 phi 1 is equal to 2 BL plus CL square, which is basically equation number 5 multiplied by 4. The next equation is phi 3 minus phi 1, which is equation 6, is equal to BL plus CL square. So this again, as usual, we are going to multiply it by minus 1. So this becomes as minus phi 3 plus phi 1 is equal to minus BL minus CL square. Now if you add both these terms, obviously the term C will vanish off, only the term B will be remaining, or basically this right hand side will have the term BL. So which means you can find out what is the value of B. So as stated, we will be multiplying with 4, equation 5 with 4 and 6 with minus 1, adding both these terms, only the term BL is there. Rearranging it, we will find out what is the value of B term as a whole. So what we have done till this particular step, the required A is equal to, phi is equal to A plus B plus Cx square. All the values of the constant A, B and C has been found out. It has to be substituted back in the characteristic equation. So this is what has been done. So the value of A is phi 1. Okay, this is basically what is the value of A. This term as a whole is B. So I can find out the characteristic equation is basically phi is equal to A plus Bx. So you have the x term that is appearing, and this whole term corresponds to the Cx square, or basically it is C, and we have a x square that is present over here. Okay, so we have just substituted all the constant values in this equation. Now we have to just rearrange it so that we are going to have the terms phi 1, phi 2 and phi 3. Right, so stating so, we are going to have phi is equal to phi 1, we will take it as a common outside. So this phi 1 is present over here, so we will put the term 1. Phi 1 is present over here, we have minus 3, 1 by L, and x over here, or basically it is minus 3 into x by L, plus again we have another phi 1 term over here. So now it is 2L square and then another x square, so it is plus 2x square by L square. So similarly, we are going to club phi 2 term. So phi 2 term is not present over here. Here phi 2 term is present. 4, 1 by L, x. So it is 4x by L. And then here again we have a phi 2 term. So it is minus 4x square by L square. 2 by L square, x square. So it is 4 minus 4 x square by L square. Last is the term phi 3. So phi 3 is present over here, minus x and then 1 by L, or it is minus x by L, and here I have x square, 2 and then by L square. So it is plus 2x square by L square. So keeping all these into consideration, this entire term is the shape function for the first node, entire term is the shape function for the second node, and this particular entire term is the shape function for node number 3. Okay, so this again you can find it over here in the next step. So as shown in the previous few steps, I've just typed it out. So we have clubbed all the phi 1 terms, phi 2 terms and phi 3 terms as a whole. Now we have found out what is the shape function of the first, second and third node respectively. Okay, so this type of coordinate system that we have used, if you try to recollect it, it is a local coordinate system. The element lies, the axis lies within that particular element. So if you try to recollect the first step, what we did was where we had a element and this is the starting point, x is equal to 0. So which means the axis is lying within the particular element. So this falls under the category of local coordinate system.